Sai Ram. Dear learners, welcome to Shri Sathya Sai Lok Seva Gurukulam online classes. Today we will be starting with class 8 mathematics chapter rational numbers. Before starting today's class, let's hear a story. A flood was threatening a small town and everyone was leaving for safe ground except for one person. The neighbor said, "Let's go." He said, "No, I have faith in God. I'll stay here." Flood waters entered the town. When it was just 2 feet water, a jeep went by, requested the man to board the jeep. He said, "No, I'll not go. I have faith in God." Soon the water level rose. He went to the second story of his building. A boat came by. The rescue team requested him to board the boat, but he was stuck like a record. "No, I will not go. I have faith in God." Soon he had to rush to the roof of the building. A helicopter went by. The people from the helicopter shouted and asked him to catch hold of the rope. The man said, "No, I have faith in God." Ultimately, the man drowned. After death, when he met his master, he angrily said, "Why did you let me drown? I had so much of faith in you." The master said, "Who do you think sent the jeep, the boat, and the helicopter?" The man was dumbstruck. So, dear learners, the moral of the story is luck helps those who help themselves. All of us need to keep our ears and eyes open for the opportunities which we come across and take them. So coming to our today's class on rational numbers. Number system is something that you have been studying for some time now. If I ask you, what are natural numbers? I am quite sure that you would all be knowing about it. So let me write it here. Natural numbers. What are natural numbers? They start with 1, 1, 2, 3, 4, 5, so on. Then you have also heard of whole numbers. Whole numbers, they start with 0, 1, 2, 3, 4, 5, so on. What about integers? Just natural numbers and whole numbers could not explain everything. For example, if I ask you, move 2 steps ahead, then the next instruction is move 5 steps behind. So how far are you from the initial position? So in this scenario, your answer cannot come in the category of either whole numbers or natural numbers. So this problem was resolved when we look at integers. So integers have negative numbers also. So if I look at on the number line, we have 0 in the center. One side we have plus infinity, other side we have minus infinity, and all the numbers on the right hand side of 0 will be positive, and all the numbers on the left hand side of 0 will be negative. So integers will have all whole numbers, and along with that negative numbers, minus 1, minus 2, minus 3, minus 4. Now we often go to the market and sometimes we say, give us half a kg of sugar. Now half is 1 upon 2. Will it come in the category of any of the three numbers mentioned here? Natural numbers, whole numbers and integers? Half is 1 upon 2. So 1 upon 2 does not come here. So here the concept of fraction comes in. Another example is, say, equation 2x is equal to 5. So what is the value of x? Value of x is 5 upon 2. So which is actually 2.5 or 2.5? So what are rational numbers? Rational numbers are those numbers which can be written in the form p upon q, where p and q are integers and q is not equal to 0. So I had written earlier 5 upon 2. So 5 upon 2 is a rational number. Why? Because it is written in the form p upon q. Both p and q are elements of integers, and q, that is the denominator, is not equal to 0. What about say minus 2 by 3? Is it a rational number? Yes, it is a rational number, because both p and q, they are elements of integer and q is not equal to 0. So this is also a rational number. What about 7 upon 0? Is it a rational number? No, it is not a rational number. Why is it not a rational number? Because in the denominator here, we have got 0. In rational number, q cannot be 0. So you should know the definition of rational numbers. Any number which can be written in the form p upon q, where p and q are integers and q is not equal to 0. In this chapter, we have to study 3 properties of rational numbers: closure, commutative property, and associative property. Today we will be studying only the closure property. Now let us look at what is closure property. We'll first be looking at closure property for whole numbers. You remember the 4 basic operations: addition, subtraction, multiplication and division. These are the 4 basic mathematical operations. So we are going to check closure property for whole numbers for addition. Then we will check it up for subtraction. And then multiplication and division. So let us look at addition. Take any two whole numbers, add them. Say 2 is a whole number, 3 is a whole number. What answer do you get? We get 5. Is 5 also a whole number? Yes, it is a whole number. Take any other whole number. 0 plus another whole number. 4 is a whole number. 0 plus 4 is 4. Is the answer, that is 4 here, a whole number? Yes, it is a whole number. So that means for addition of whole numbers, the closure property is applicable. Take any example. Say 5 plus 1. 5 plus 1 is 6. 5 is a whole number. 1 is a whole number. And answer that we have got 6 is also a whole number. So we will write here whole numbers are closed under addition. I hope it is clear. Now same way we are going to check for subtraction. Take any two whole numbers. I have taken 3. Another whole number that I have taken is 2. 3 minus 2 is 1. So answer that you have got by subtracting two whole numbers, you have to check whether the answer is also a whole number or not. In this case, 3 minus 2 is equal to 1. So 1 is also a whole number. Now what about 5 minus 3? 5 is a whole number, 3 is a whole number. 5 minus 3 is 2. Is 2 a whole number? Yes, 2 is a whole number. Take few more examples. Now suppose if I take it 2 minus 3. 2 is a whole number and 3 is a whole number. What answer do we get? We get minus 1. Is minus 1 a whole number? No, it is not a whole number. So we will say that whole numbers are not closed under subtraction. Now let us look at multiplication and then division. What do we have to do in these cases? Same thing. Take any two whole numbers. Let's take simple 2 multiplied by 3. We are checking it for multiplication. So the mathematical operation will be multiplication. 2 multiplied by 3 is 6. Take few others. 0 multiplied by 1 is 0. We have taken two whole numbers. The answer which comes, is that a whole number or not? Yes, 0 multiplied by 1 is 0. 0 is a whole number, 1 is a whole number, and the answer that we have got 0 is also a whole number. In the first example, we had taken two whole numbers, 2 and 3. Answer is 6, and 6 is also a whole number. Try any other whole numbers. 1 multiplied by 7. 1 is a whole number, 7 is a whole number, and our answer which comes 7 is also a whole number. So we will say that whole numbers are closed under multiplication. Method is very simple. Whatever mathematical operation is there, we have to do that. And since we are checking it for whole numbers, so the first two numbers that we will take will be whole numbers, and we have to check the answer that we get, is that also a whole number or not. Now let's check for division. 4 divided by 2. 4 is a whole number, 2 is a whole number. 4 divided by 2 is 2, which is a whole number. So in this case, the condition is satisfied. Now what about 2 divided by 4? 2 divided by 4 is 1 by 2. Is it a whole number, 1 by 2? No, it is not a whole number. So the whole numbers, they are not closed under division. So let's quickly see what have we for the 4 mathematical operations for whole numbers. For addition, whole numbers are closed under addition. For subtraction, whole numbers are not closed under subtraction. Then for multiplication, whole numbers are closed under multiplication. And for division, whole numbers are not closed under division. Now let us look at closure property for natural numbers. Same method, we have to first see for addition. Natural numbers. So let's take two natural numbers. 1 plus 3. 1 plus 3 is 4. 1 is a natural number, 3 is a natural number, and the answer that we have got is also a natural number. Take any other. 2 plus 5, 7. 2 is a natural number, 5 is a natural number, and 7 is also a natural number. You can take any other example also. So we will say natural numbers are closed under addition. Then let's check for subtraction. Four is a natural number, 1 is a natural number. 4 minus 1 is 3. 3 is a natural number. We need to take more examples. Let me take 2 minus 5. 2 is a natural number, 5 is a natural number. 2 minus 5 is minus 3. Is minus 3 a natural number? No. 1 minus 3. 1 is a natural number, 3 is a natural number. 1 minus 3 is minus 2. Minus 3 and minus 2, they are integers. They are not natural numbers. So therefore, natural numbers are not closed under subtraction. Let us check for multiplication. And then we will see for division also. Take any two natural numbers. 1 multiplied by 3 is 3. Another two natural numbers. 2 multiplied by 5. 2 is a natural number, 5 is a natural number. 2 5s are 10. 10 is a natural number. 3 multiplied by 4. 3 is a natural number. 4 is a natural number. Answer which we get 12 is also a natural number. So hence we can conclude that natural numbers are closed under multiplication. Now what do we get for division? 1 is a natural number. 3 is a natural number. 1 divided by 3 is 1 upon 3, which is a fraction. It is not a natural number. So from here only we can conclude that natural numbers are not closed under division. So let us see what have we done for natural numbers. For addition, the natural numbers are closed. For subtraction, natural numbers are not closed. For multiplication, natural numbers are closed. And for division, natural numbers are not closed. So if you see for whole numbers as well as for natural numbers, it is same. For addition, both whole numbers and natural numbers are closed. For subtraction, they are not closed. For multiplication, both natural numbers and whole numbers are closed. And for division, both natural numbers and whole numbers are not closed. So we have done closure property for natural numbers and whole numbers. Now let us look at closure property for integers. So same method we will be adopting here. Let us look at addition. Take any two integers. Say, let me take negative one also. -1 plus 2. -1 is an integer and 2 is also an integer. What answer do we get? We get 1 plus 1, which is an integer. Take any other example. Say 0 is an integer and -5. So 0 minus 5 is -5, which is also an integer. You can take some other examples also. Say -3 plus 3. We get 0, which is also an integer. -3 was an integer, 3 was an integer, 0 is also an integer. So we will say that integers are closed under addition. Now what about subtraction? Take example, and you can take any example, but you need to take 4 or 5 examples and different kinds to come to a conclusion. For subtraction, say I have taken -1 and from here I'm subtracting 2. -1 is an integer and 2 is also an integer, and we are subtracting it. We get the answer -3, which is also an integer. Let me now take, say, first number as positive. I take 3 is an integer. And from here I am subtracting -1, which is also an integer. So this will become 3 plus 1 is 4, and 4 is an integer. 0 is an integer. Let's subtract 5 from it. What do we get? We get -5, which is also an integer. So the conclusion is integers are closed under subtraction. Now we will be checking for multiplication and for division. Take any two integers. -1 is one integer and 3 is another integer. Multiply them, we get -3. And this answer -3 is also an integer. Another example, 0 multiplied by -4. 0 is an integer, -4 is an integer. Multiply them, we get 0, which is also an integer. Some other examples can also be taken. -2 multiplied by -5. We will get the answer +10, which is also an integer. -2 is an integer, -5 is an integer, and the answer 10 that we have got is also an integer. So, we will conclude that integers are closed under multiplication. Now let us look at division. -1 is an integer divided by 3, which is also an integer. We get the answer -1 by 3. Is -1 by 3 an integer? No, it is not an integer. It is a rational number. So from here only we can conclude that integers are not closed under division. You can take some more examples also. Say, let me take 2 is an integer divided by 0. 0 is also an integer. Will you get any answer here? No. So, this is another example which tells us that integers are not closed under division. If you had taken the example, say, 2 divided by 4. 2 is an integer, 4 is an integer. Answer is 1 by 2. 1 by 2 is not an integer. So, what we have written, integers are not closed under division, is the correct statement. So, for integer, we have seen that integers are closed under addition. They are closed under subtraction. They are also closed under multiplication, but integers are not closed under division. Now we will see closure property for rational numbers. Just to quickly remind you, what are rational numbers? Numbers which can be written in the form P upon Q, where P and Q are integers and Q is not equal to 0. Here also we have to see for addition, we have to see for subtraction, then for multiplication and division. Let's take some examples. 1 upon 2. 1 upon 2 is a rational number. Add another rational number and let's take the number as fractionals only. 3 upon 4. So what answer do we get? Take the LCM. It is 5 by 4. Is 5 upon 4 a rational number? Yes, it is a rational number because it is written in the form P upon Q and the denominator Q is not equal to 0. Take any other example. Suppose you have taken -1 by 3. Add 2 by 3 to it. Both -1 by 3 and 2 upon 3 are rational numbers. Add them. We will get 1 upon 3, which is also a rational number. You can take any other example, and the conclusion that we arrive at is that rational numbers are closed under addition. For subtraction also, we'll take some examples. Let us take the above examples only. 1 upon 2 is a rational number. 3 upon 4 is also a rational number. Take the LCM. We'll get 2 minus 3. And here we get minus 1 by 4. So is minus 1 by 4 a rational number? Yes, it is a rational number. You can take any example. Say 3 upon 8 minus, let me take a negative number here, minus 1 by 4. Both 3 upon 8 and minus 1 by 4 are rational numbers. Now when we have to solve them, what will we get? We'll get 5 by 8, which is also a rational number. So, rational numbers are closed under subtraction. Rational numbers, they are closed under addition. Rational numbers are also closed under subtraction. Coming to multiplication. Take any two rational numbers. 1 upon 2 multiplied by 2 upon 7. 1 upon 2 is a rational number. 2 upon 7 is a rational number. We get the answer 1 by 7, which is also a rational number. Minus 1 by 3 multiplied by 4 upon 5. Minus 1 upon 3 is a rational number and 4 upon 5 is also a rational number. What do we get? Minus 4 upon 15. Minus 4 upon 15 is also a rational number because it is written in the form P upon Q and Q is not equal to 0. Any number you take, even if you take 0 multiplied by minus 3 upon 8, what do we get? 0. 0 is a rational number, minus 3 upon 8 is a rational number, and the product that we have got, which is 0, is also a rational number. So we will conclude rational numbers are closed under multiplication. Let us check for division. One upon 2 divided by 2 upon 7. How do we solve it? We'll change the division sign into multiplication and take the reciprocal. So we get 7 upon 4, which is a rational number. What about 1 upon 2 divided by 0? 1 upon 2 divided by 0. It is not a rational number. Let's take 2 divided by 0. 2 divided by 0 is not a rational number, because that is the prerequisite that q cannot be 0. So rational numbers are not closed under division. So for division, we have seen that for addition, multiplication and subtraction, the rational numbers are closed. But for division, the rational numbers are not closed. So let's quickly fill in the following table. Rational numbers, we have just now done. They are closed for addition, subtraction and multiplication, and they are not closed for division. What about integers? They are closed for addition, they are closed for subtraction, they are closed for multiplication, but they are not closed for division. What about whole numbers? For addition, both whole numbers as well as natural numbers, they are closed. What about subtraction? For both whole numbers as well as natural numbers, they are not closed for subtraction. Multiplication? Yes. Both whole numbers and natural numbers, they are closed under multiplication. And what about division? We have already done that whole numbers are not closed under division and natural numbers are also not closed under division. So from here, you get an overview that for division, all four of them, natural numbers, whole numbers, integers and rational numbers, they are not closed. For multiplication and addition, all four of them are closed. Whereas for subtraction, whole numbers and natural numbers are not closed, but integers and rational numbers are closed. I hope the closure property is clear to you. For your homework, I am giving you a task. The task is to see if you can help the team. There are 4 team members: alpha, beta, gamma and theta. They are 4 friends who went on an adventure to a jungle, and somehow they were caught in a situation. And the situation was that some animals came after them. And they had to cross this bridge in the dark of the night. Each person had different timings for crossing the bridge. The speed was different. Alpha took just 1 minute to cross the bridge. Beta can cross the bridge in 2 minutes. Gamma is quite slow, can cross the bridge in 5 minutes. And theta is injured, but he is the most intellectual out of them, can cross the bridge in 10 minutes. So they have to go from this side to the other side. From A to B they have to go. The bridge has got wooden planks. It is over a gorge. They have to be very careful while crossing the bridge. Condition is only 2 people can cross the bridge at one time. Only 2 people can cross the bridge at a time, and carrying the lantern is must, because it is absolutely dark. If they don't have the lantern, they'll fall down. So carrying the lantern is compulsory. So how will they cross? Only 2 people will go. If 2 people go to the other side, one has to come back with a lantern, and then 2 will again go along with the lantern, and one has to come back. In this way, the whole team has to come to the other side, and they have got only 17 minutes with them. Please see if you can help the team who should be going first or what the sequence should be. And we have to save the entire team. They cannot leave behind anyone, and they have got only 17 minutes before the animals reach them. And what are they going to do at the end of the 17 minutes? The moment all of them are on the other side, they will cut the rope of the bridge so that none of the wild animals is able to cross them. So I leave you with this. Hope you are able to find the solution and help the team. That is all for today. Thank you so much. Om Shri Sai Ram.